Okay, so today experiment would be your ABCD parameters. Okay, I will we'll do the hardware segment. What in our laboratory? Okay, we have one particular model of T and pi safe. So for that, we'll be doing this experiment. Okay, so before that, let's first we will see is your these ABCD parameter. Okay, now ABCD parameter, also known as chain of transmission line parameter, okay, are generalized constant used to help model transmission line. Moreover, specifically ABCD parameter are used in the two-port representation of a transmission line. The circuit of such two-port network is shown. Okay, this is the transmission line, and you could account that IS, VS, and IR, VR. Okay, they are the 2 point that is PQ and RS. Okay, this is a very T model of transmission line where R and L is being represented as Z by 2, Z by 2, and this is your C. It is a T model. Again, you will have a pi model, okay, in our laboratory, okay, where one capacitor will be here, one capacitor will be here, that is your C1 and C3, and C2 would be eliminated, okay. Now, a major section, okay, of power system engineering deals in transmission of electrical power from one place, uh, that is your generating station, to the load. Okay, that is substation of residential homes. These are the loads, so we consider load with a maximum efficiency. Okay, so it is important for power system engineers to be through with the mathematical modeling of how this power is transmitted. Okay, now ABCD parameter, okay, are of, and a two-port model is usually simplify these complex calculation. We have studied this ABCD parameter in the network theory also in the part of two-port network. Okay, to maintain this accuracy of this mathematical model, okay, transmission lines are classified into three segments, that is your short, medium, and long transmission. Okay, the formula for these ABCD parameter will change. They will change depending on the length of the transmission line. Okay, this is necessary. Okay, since certain electrical phenomena such as your corona discharge or Faraday effect only come into play when dealing with a long transmission line. Yeah, we could account in short transmission line. You can't find, that is that it is Faraday effect. Okay, that will be accountable only in the this segment only. Okay, now as the name suggests, a two-port network consists of an input port, that is your PQ, okay, where you could account. Okay, now so as name suggests, a two-port consists of a input PQR and RS. Okay, see, okay, this has a four terminal, that is a linear passive binary network. Okay, I try to call. Okay, a voltage, the input voltage and input current can be expressed in terms of output voltage and output current. Each port has two terminals, at this two. Okay, it's a pair of terminals. Okay, thus is essential a two-port, four-port circuit having this. Okay, now over here the sending end voltage is V and sending end current is this, receiving end current is this, receiving end voltage is this. Okay, given input port is PQ and output port is RS. Now the ABCD parameter of the transmission line provided, okay, the link between the supply and receiving end voltages and current. Okay, considering the circuit element to be linear in nature. Okay, Thus, the relation between the sending end voltage and receiving end voltage specification is used because with the use of these two formula. Okay, because using this formula only and following certain norms, you could find the parameter value, that is your A, B, C, D. Those parameters could be found. Okay, now if we say that Vs equals to AVR plus BIR. Okay, this is one equation. Second is your ISCVR and DIR. Okay, using these two equations, we could find A, B, C, and D, because out of these four parametric values, that is VS, IS, VR, IR, anyhow you would be getting a three. Okay, three data you would be available. Okay, now, so how you could find? So first most thing is uh, open circuit. Okay, that is a open circuit. Okay, and then open circuit of receiving end. Open circuit at B receiving end. Okay, at the receiving end. See, so what you are doing at receiving end, it is open circuit, so only VR would be there and IR would be zero. Three data are there, three R data are there, the VS is there, IS is there, and VR is there. No IR, no IR. So what two values we will be getting? We will be getting your A and C value. Same process you have to apply after connecting all the equipment and T model or pi model. We have to once open circuit and one short circuit, so we'll get the VS, IS and VR value or VS, IS and IR value. Then accordingly we could find your AB and AC and BD respectively. Okay. Now, in order to determine the ABCD parameters of the following transmission line, let us impose the required circuit condition in the different cases. The first case is you have to do open circuit. Okay, the receiving end is open circuited, meaning the receiving end current IR would be zero. Okay, applying these two, so we'll get ultimately your A, that is your VS and VR, that IR equals to zero. So this V and VR is a unitless segment. Okay, this is a dimensionless or unitless, whatever you call that. Okay, so this is a unitless segment. Okay, thus it implied that on applying open circuit condition, ABCD parameter, we get the parameter A as the ratio of sending end and voltage and receiving end voltage. Okay, since dimensional wise, A is the ratio of voltage to voltage A. Okay, it is a dimensional pairs. Okay, now similarly it goes for your another parametric value, that is your C, where it is your IS by VR, which is called your admittance. Okay, this is an admittance parameter. Okay, it will be in mho. So thus it implies the applying to the open circuit condition to the ABCD parameter of a transmission line, we get the parameter C as the ratio of the sending end current or to the open circuit receiving end voltage. Since dimensionless, okay, see, since dimension wise C is the ratio of current and it should be unit, should be mho, and unit of admittance is mho. So this will be your admittance. Okay, the C is a open circuit conductance and will be given by CIVR. Okay, now the another is short circuit at receiving end, receiving end. This is your network. Okay, BS, IS, IR, VR. Okay, now receiving end is a short circuited, meaning receiving end voltage VR equals to zero. Now, applying this condition to equation 1, we get VS equals to A plus A0 VR. So on this shortcut, in this method, you could be getting yes, that B equals to Vs by IR, that is your impedance, that will be counted as a Z. Okay, that is your ohm. Okay, this is the resistance for ohm. Now the B value, okay, B value is being got this. Now what will be D? D would be your Is by R. It's again a dimensionless parameter. So this is the value. Okay, so therefore parameter, okay, A equals to Vs by VR, this is voltage ratio, is unitless, and B equals to Vs by IR, that is short circuit resistance, that is ohm, or admittance, whatever you call. C by IS by VR is open circuit conduction, that is your mho, and D is IS by IR, that is current ratio, that is also unitless or dimensionless. Okay, this is the only thing that we gonna discuss. Okay, now we'll follow two of the methodology. Okay, first I will help you out in understanding in MATLAB coding when you have to do MATLAB. Okay, then after this we'll go with your practical session. Okay, where we'll discuss that. Okay, now so for now practical part, let's move to the this that to the MATLAB coding. Okay, so we'll stop sharing over here. We'll change sharing to MATLAB. Okay, instead we will be sharing the screen. Okay, share screen. From here we could account MATLAB. Okay, we'll get you to the MATLAB. Okay, now so first of all we'll arrive in the live editor. Okay, this is your live editor. We'll write in live editor and we'll be running it. Okay, so we'll first write this particular segment. Okay, so let's write and let's proceed with our further process. Okay, now first we'll write the heading. We'll write A B C D parameter. Okay, we'll have a ABCD parameter matrix and justification. Okay, we'll write this. Okay, these are not required. Okay, so we'll first let assume the parameter value. Okay, we'll give our length. Length could be, let's take 300 kilometers. Okay, then let's take a resistance value. Resistance value would be taking 0.016. That is your resistance per kilometer. 0.0. Okay, now we'll take inductance. Inductance equals to 0.97 e to power minus 0.03 value. Okay, capacitance would be your 0.0115 e to power 6. Okay, would equal to, okay, 0.01. Okay, fine, we'll take this. Let's take F equals to 50. Okay, this data is also been done. Now what we'll take a kilovolt. Okay, L to L. Okay, kV, that would be your L to L equals to 500. Okay, that will be 500. Then we'll take MVA. Okay, equals to 1000. Okay, now we'll make a NVA 3 means 3-phase MVA as a 1000. Okay, then we'll give a power factor as 0.8 value. Okay, and we'll give flag equals to 2. This flag we could say change. Okay, we'll give a command over here. We'll give a command over here, that is your flag equals to 1. Okay, for leading power factor. Okay, we'll write over here power factor. Okay, and flag equals to 2 for lagging. Okay, we'll put this value. Okay, now let's start the code. This is the data that is will be used universally. Let's start the code. Okay, So foremost thing is the very important line that everyone writes. Okay, that is two line, that your CLC clear all. Okay, this is what we write. Now we create a matrix. We create matrix. So mat, let's give this part. Okay, one matrix is this, and another matrix would be this. Okay, two matrix will be there. Now we'll provide, means we can choose that which kind of input we are taking, or which kind of uh, line we are proposed. Okay, so this option is also provided. So let's give that lm is equal to, okay, input, then bracket, okay. Now we can give an option also. So we'll write enter line model. Okay, line model. So we'll give a column, we'll give this as a one, or not now. Okay, one for sort, two for medium, three for medium T. Fine. Okay, so let's give a name. Let's give a name over it. Okay, we'll give a heading in this. The heading would be your line model, that is your lm, okay, equals to 1. Okay, for, okay, over here it is given, it is given. Okay, we'll just write a line model. Everything has been given as an input. So we don't try to change. Okay, now, so this would be your total L would be your inductance, um, inductance into lm. Okay, so total L value would be calculated total. Okay, that value it is given per kilometer value. In above it is being mentioned, that is your per kilometer value. We will calculate all L. Okay, now we'll calculate C equals to cap into again lm, that is your length. Okay, not lm, it's length. Oh, sorry. Okay, this length. Okay, so L is 10, C is 10. Okay, resistance is total resistance would be RES into length. Okay, this is done. Now XL value, how could you find XL? XL would be equals to what is the formula? We have formula as 2 into pi, 2 into pi and into F into L value. So this is your XL. We'll write XC, or we could directly instead of finding XC, what is the line? We have Z. Okay, we have Z. Z equals to what is your Z? That is your R plus Ij, right? So complex. Okay, whenever you have to write complex, you'll have to write this. This will be your R, comma. It will be your XL. Hopefully, it will be your XL. So this is your Z. Okay, this is your Z. Now Y would be your complex complex 0.0 comma 2 into pi I into f into c. Okay, this will be your Y. Now here comes the role. Will player, okay, will ask if lm, okay, will ask ml equals to 1. Okay, if it is true, then your mat, that is your matrix. Okay, this matrix, okay, would equals to 1.0 z. This what we'll get. Okay, then we'll have else if. Okay, we'll write else if lm is equal to 2. Okay, we'll write else if equal to 2, your this mat would be equal to 1 z okay, LZM 0.01. Okay, this will be a 2 into 2 matrix. Okay, this is what we'll get. This is for the first segment. Okay? This is for the first segment. Lm equals to 1. Okay, so if 1 है means short है तो means 1z0 0.0 1.0. okay, होगा okay. When it is L equals to 2 means medium pi. Okay, if it is medium pi, okay, so when it is your medium pi होगा तो इसका क्या होगा वैल्यू? That will be your 1. Okay, 1 plus y into z by 2. We have showed you, okay, 2 transmission lines. What would be your z by 2? तो ये हो जाएगा 1 plus y into z by 2. This part, okay, this part is done. दूसरा हो जाएगा z. Okay, this would be your first. Now what will be your c? Your c would be your y into mm, 1, same thing, okay, 1 plus y into z by 4, 1 plus y is equal 4. Okay, this will be your one. Now second matrix would be above 1. Okay, that is 1 plus z by 2. Okay, we'll copy this and we will be pasting over here. Okay, this is also done. When equals to 2, else. Now question comes else. Okay, now where else mat equals to this figure. Okay, यहाँ पे क्या होगा? Okay, it will be same thing, right? Same question would be there. Copy. Small changes would be made. Okay, when it is a pi. So ये हो जाएगा 1 plus y z by 2. This will be your z y plus 2, this plus 2. Okay, this is one particular segment. Okay, yeah, correct, I am correct. Okay, this will be the term. Means if 1 it is this, when it is 2 it is this, when both are not there, then it's obviously it will be your 3. Okay, so when 3 comes it will be there, means it will, for the t it will be in this, for pi it will be this, and for only short medium your matrix would be this matrix of ABCD parameter. Okay, that matrix would be there. Now when when this equals to, I'm taking this equals to mat 1 comma 1. Okay, this is a coding. Okay, mat 2 comma 2, sorry, minus mat 1 comma 2 into mat 2:1, 2 comma 1. Okay, this is the value. Okay, this is the value. Now so what we have to find, we have to display the ABCD parameter what just we have completed. So on finding this, okay, there would be your ABCD constraints constant. Okay, this is what we are gonna find. Okay, next would be your display will find this value. We'll repeat, we have to repeat this time this value. Okay, display part v, this would be your AB value. Okay, then this will be your finding your mat. This is the space thing. Okay, that will be the providing the space. You could reduce that space as well. Okay, these are the for the space. Okay, you could reduce the speed, then we'll display. Okay, we'll display your AD minus BC value equals to, we have to just to verify whether what it is. Okay, now display your x6. Okay, this value we have to display. Fine. Now, so what we could display now? Let's run and see what parameter we get right now. Okay, so there is a constant over here. Okay, invalid expression while calling a function or a index variable. Okay, we'll put a star mark over here and we'll put a star mark. Okay, this hidden part over here, and we could run this. Okay, play run, enter which type of this it is. We'll press 1. Okay, over here result will be reflected. Just a minute. Add from enter 1. Sorry. It's IND only, na? Yes, let's change with I. Let's change with I. This one, enter. Let's see, we get this is unvalid. Okay, this is not been defined. Okay, this is not presently defined. Okay, now so there would be small changes in this what we have to made. Okay, we are not getting the value. So there is a small error in this. Let's fix out the error. Okay, this is your undefined parameters. Okay, this is undefined function variable length. Okay, this is undefined variable. Okay, let's write. Okay, we'll see, we'll write this, we'll see. This one showing again. Let's see. Enter 1. If we are getting value, okay, no, we are not getting the value. Still it's showing the same issue. It's showing the same problem. Undefined function or variable. Okay, so what we'll do is, mm, we'll fix this issue. Okay, mm, by fixing your mm, undefined function or variable, that is vr. Okay, undefined function. Okay, let's run now and see what is happening. Yeah, it's coming. See over here. This is your ABCD parameter. Okay, we haven't gone on finding your other terminals. Okay, only ABCD. We'll delete this segment. Okay, this is your matrix. Okay, we'll give two value, so you could assume that values are changed. Okay, this is your ABCD and this is your code and this is the matrix. Okay, this is your ABCD matrix, and we could get that AD minus BC equals to 1. We are getting. Okay, so you could run again of enter. You could provide 1 and you could see the different data would be there. That's will be for time. Okay, it's coming 0.0100 plus 0.000 I plus 0.400 plus 1.0970 I. This is your 0.000 0.00 I 0.0. Okay, you could calculate. Okay, this is formula what we have used. Okay, here if we are choosing L, so it will be your 1 Z value, 0 and 1 value. Okay, see over here, it is coming 1 1. This will be Z and this will be 0. Okay, when we are running this, we are choosing 2. Okay, when we are choosing 2, so we are getting this particular value, that is over here. Okay, this value. Okay, where Z is 0.4001 plus 1.9. Okay, in the previous question also Z was same, and this is your 1 plus y into Z by 2, and this is your y into 1 plus Z by y by 4, and this is this value. Okay, all values are same for different parameter. For same value, your AD minus BC is value, or either we are choosing your D, V, and C. Okay, we'll write 3. We are not choosing 1 or 2, we are choosing 3. So we'll give the different value over here. Again, 0.943 I, 0.4666 this, and this, and this. Okay, we'll got this value from this equation. This equation. Your y is your 0. Y is your 0. So these data are coming. So this is all about this particular segment. Okay, now what we have to do is we will seeing this particular thing in hardware. Okay, in our lab, whatever the equipment we are lab. So online we have done, so we'll now see for the hardware. So let's see the manual first from the hardware, then we'll proceed to that particular segment. Okay, so we'll start with the hardware segment. Okay, okay, we'll see this. Okay, we'll see this, we'll go accordingly to this particular point. This will be the circuit. Okay, where RL is provided. Okay, it is in C format. This is your segment. You have to find uh, ABCD parameter. These are the formula we have already discussed with this. Okay. Okay, this is your procedure. We could account procedure for 5. Okay, so we'll go with the figure. If I have, okay, don't have figure, I will be telling you about this and we'll proceed with that. Okay, over here this part was not there. Let's, okay, make this as your L1 R1, L2 R2, okay, L3 R3. This is your C1, C2, C3, and these figures are, G is not there. Okay, G is not there over here. Okay, in our equivalence again, same it will be there, and we'll also, okay, let's make it very clear. Okay, hold on a minute. We'll paint with white color. Okay, this would be hidden. Okay, this would be hidden, this would be hidden, this would be hidden. Okay, this is hidden. Now let's write the value. We'll take a black color. This is your N1. We'll not write over there, we'll write over here. Okay, 1 1 1. Okay, that is 2 2 2 3 3 and 3. This is the circuit we have. Okay, using this you could draw the T network and pi network. Now how you could draw T network? T network could be drawn by adding the, I will put the circle part. Okay, this is the circle unit and this particular segment. Okay, with the help of this we could draw the T network. Okay, now for the pi network, what you have to do, you have to go to add, okay, you have to eliminate this part from the figure. Okay, the C2 would be not added, only C1 and C3 would be added. We'll see this in a that particular segment in a figure. Okay, okay, let me first erase this and we'll see the procedure. Okay, this is the procedure for T network. Let's erase this segment also. Okay, this is a procedure of C network. Okay, ensure that thing. So these are the process we have to follow. But see over here, point number 7 and 8. Connect resistance R1, R2, and terminal to the circuit diagram terminal, that is R1, R2. In a circuit, you would be seeing that figure would be there, and below the part would be provided. And connect L1, L2, and the terminal with the L1, L2. Okay, C capacitance would be calculated as, okay, C2 would be connected with the C2 terminal. There will be no use of C1 and C3 in that particular point. Okay, after comparison, MCB is there, MCB put out, would make the rated voltage, that is your 220, and assume the, okay, and for, as we have studied that to calculate your A and C parameter, you have to do open circuit. So the output terminal would be opened, only input terminal would be present at that particular line. Okay, same. So after going to this, when you are going for your, okay, open circuit, then it will be having your short circuit. Okay, for short circuit, what you have to do, okay, see, for the short circuit, what I have to do, only sort that particular output terminal. So you will be finding your the other two element, that is your B and D. Okay, so these two process are there, you could see. Okay, we will see this entire segment. See over here for the pi, you could see over here R1, R2 will be calculated connected to the R1, R2, L1, L2 will be connected to the L1, L2, and C1 terminal would be connected to the C1, C3 would be connected to the C3. No, C2 would be used. Again, in this also we'll be doing your open and short circuit test to finding your that two value. Okay, this is all about your thing. So what we have done, studied your ABCD parameter. We have seen using coding how to get the ABCD parameter. In that coding, we could more proceed on finding a lot of parameter value, but will only require the ABCD parameter. So we got the ABCD parameter. Now next step is we'll find the we'll see these lab manual was for the practical. So we'll see that practical. So our practical will be done in the hardware in the college. Okay, we have a model. Okay, we have a ABCD parameter model that is of, I think so, from Mars. Okay, we'll move at that. Okay, so in afternoon we'll start.